Namaste. Welcome to Indian Knowledge Systems Primer Course for Children offered by the Anaadi Foundation. In this particular session on Bharatiya Ganita, we will look at an introduction and delve a bit more into the history of what Bharatiya Ganita is. Indian civilization has been a cradle not only for refined civilizational best practices but also for numerous scientific developments. Ancient Indian mathematicians achieved many significant breakthroughs and created wonderful pedagogical approaches to learning mathematics. We would gain from learning how Indian mathematicians developed ideas and approached different problems for the joy of doing math. Techniques to hone mental arithmetics, improve mathematical thinking through puzzles posed by Indian mathematicians have significant benefits. One of the most unique features of the Indian sciences and the knowledge system at large has been the transfer of knowledge through poetry or verses which are orally transferred from generation to generation. Just think about this. How would it be if you learnt math, astronomy and other subjects using verses which you could just sing and easily commit to your memory? This is precisely the genius that exists across the Indian tradition, where complex knowledge systems have been composed in verses which can easily be set to music. This is one of the most unique things about the Indian civilization and the knowledge which we have inherited. Indian mathematicians too have shown this particular skill by weaving principles of mathematics into sutras and delightful verses without losing clarity or precision. So now you can learn science, math and astronomy using verses which are possible to be sung. Key eras of development of Ganita. There is evidence for usage of mathematics dating way back to the Vedic era and has continuously evolved since then. The key developmental periods of Bharatiya Ganita or Indian mathematics are looked at in three phases. First is mathematics in the ancient era, which is prior to 500 BCE. The second is mathematics in the classical period, which ranges from 500 BCE to 1350 CE. And the third is mathematics in the medieval period, which is from the 14th century till about the 18th century. And this period is described as the golden age of mathematics in India. Now, let us look at some achievements of the ancient period or the Vedic era in Bharatiya Ganita. The Indus Valley civilization, also called the Harappan civilization, dates back to roughly 2500 to 3000 BCE. Urban planning and geometry was a crucial part of this civilization. The urban nature of civilization necessitated knowledge of practical geometry for city planning. Geometric sophistication was also seen at several Harappan sites. Evidence of geometric understanding found in patterns on pottery, including utilization of circles and triangles, also exist. The Harappans used the knowledge of mathematics and geometry in their agricultural practices, in trade practices, and so on. We also see, with evidence from the Harappan civilization, a lot of use of tools, which tells us that artisans were adept in using dividers for scratching designs on pottery and so on. The presence of geometrical motifs such as triangles and circles indicate familiarity with several geometric concepts. The Harappans also had a well-defined system of weights and measures, which was sophisticated and reveals a well-developed understanding of arithmetic. Evidence of brick building technology tells us that the Harappan people knew the ideal ratio of length, breadth and thickness of a brick for effective binding strength, which showcases an advanced level of practical geometry and knowledge of mathematics. The Vedic era. The decimal positional names have been found in the most ancient literature, which is the Rig Veda, dating earlier than 2000 BCE. There are several mathematical concepts dealt with in some of the Vedic mantras itself. The knowledge of the operations of addition, subtraction, multiplication and division are evident from looking at these mantras. There are also several progression series mentioned within them. In the Yajurveda Samhita, for instance, we have the following list of numeral denominations proceeding in the ratio of 10. So, beginning with Eka, 1, one has names and denominations which go up to 10 raised to the power 12. The same list again occurs in the Taittiriya Samhita and with some alterations in the Maitrayani and Kathaka Samhitas as well as other places. Number classification systems were also developed. The numbers were classified into even or yugma, literally meaning a pair, and odd or ayugma, literally meaning not pair. The 0 has been called Shudra. The negative number has been indicated by the term Anricha, while the positive number is denoted by Richa in the Atharva Veda text. Vedic literature is also concerned with the building of altars. Manuals for constructing such altars were authored as a class of texts which are called the Shulba Sutras. Shulba Sutras are the earliest known works in Indian civilization that are highly relevant to the field of mathematics. They come and form a part of the Kalpa, which is one of the Vedangas. We will learn more about what Vedangas are in our subsequent lectures. In ancient times, all the branches of knowledge which used to be studied by the scholars along with the Vedas were called the Vedangas. While it is believed that there were several Shulba Sutra texts which existed, 7 different texts have been identified by scholars. These are Shulba Sutras of Baudhayana, Apastamba, Katyayana, Manava, Maitrayana, Varaha and Vadhula. The Baudhayana Shulba Sutra, which is authored by Bodhayana and hence named after him, is the most ancient one and has been dated prior to 800 BCE. It is made up of 3 chapters constituting about 520 sutras. The Baudhayana Sutra contains geometric procedures and principles for constructing altars. It is important to note that what we today understand as the Pythagorean theorem was in fact given by Bodhayana in his Shulba Sutra as the Bhuja Koti Karna Nyaya. The quest for pi dates back in the Indian mathematical tradition all the way to the Vedic era. The quest for pi began because of the challenge of constructing the 3 primary altars called the Gaharapatya, which you can see here, the Ahavaniya and the Dakshina with equal surface area. So the challenge mathematicians had to face was to construct a circle, a square and a semicircle with the same surface area. This problem, also known as the quest for pi, has been dealt with in the Vedic era itself. In the Vedic era, we also find the construction of different kinds of chittis, such as those shown here. As you can see, both of these chittis are created or constructed using several mathematical forms. For such constructions to happen, the rational approximation of surds would have been calculated. These are just a few glimpses of what existed in the Vedic era in the field of mathematics. To appreciate this, in subsequent lectures of this course, we will learn a few techniques from these masters and see how we can master them ourselves. Now, let us look at some key highlight achievements of the classical era in Bharatiya Ganita. In the classical period, Panini's Ashtadhyayi, which was composed around 500 BCE, includes methodologies with mathematical influence. Pingala's Chanda Sutra, composed around 300 BCE, contains various algorithms related to combinatorics and the use of binary number systems, which has equivalents in today's field of computation as well. The ancient Buddhist and Jaina literature composed around 600 BCE to 400 CE also contains several mathematical insights. The Jainas consider Ganita to be an important part of their spiritual study. Another important work believed to have been composed in the early centuries of the Common Era is the Bhakshali manuscript, which has a very interesting story of discovery behind it. The Bhakshali manuscript was in fact discovered in 1881 by a farmer in a place called Bhakshali near current Peshawar. This manuscript, of which we only have 70 pages existing today, is written on birch bark leaves. This manuscript includes algebra, arithmetic and a bit of geometry and is believed to be only partially complete. From around 5th to the 12th century CE, Indian mathematics was considered to be at its peak. This period begins with the great works of Aryabhata, Varahamihira, Bhaskara first and Brahmagupta. By this time, Indian mathematicians had fully perfected most of the arithmetic, algebra, geometry, trigonometry and commercial mathematics that are taught in schools today. They had also made great advances in solutions of indeterminate equations, computation of sines, combinatorics and other topics which are not at all taught at the school level. In the course of this Bharatiya Ganita lecture series, we will see some of the techniques from these mathematicians and learn them. While it is a popular misconception that Aryabhata invented the zero, it is certainly not the case. The invention of zero and in fact the entire decimal place value system has been existing since the Vedic time itself. Aryabhata's work Aryabhatiya, which is roughly dated around 499 CE, has a lot of advanced procedures in arithmetic, algebra, geometry and trigonometry. In the subsequent Bharatiya Ganita lectures, we will have the opportunity of learning some techniques from Aryabhata himself. Varahamihira, another tall figure in Indian mathematics, was a polymath himself. Because of Varahamihira's work, we have the currently existing 5 Siddhantas in astronomy in the Pancha Siddhantika texts. Varahamihira's Brihat Samhita, which is an encyclopedic work, contains a lot of mathematical operations, of which we will see a small example as a magic square in our subsequent magic squares lectures. A lot of Aryabhata's work is in fact accessible and understood by us today owing to the commentaries of Bhaskara I. Brahmagupta, who is another great mathematician in the Indian tradition, gave us the mathematics of zero and negative numbers as well as cyclic quadrilaterals and the development of algebra. Between the 8th and 11th centuries, there flourished many great mathematicians in India. Sridhara, Lalla, Govindaswamin, Mahaviracharya, Prithudakaswamin, Munjala, Aryabhata, Sripati and Jayadeva are just some of these names. It is unfortunate that today these are not so well known and in fact we know very little about these mathematicians. Of special note is the Chakravala algorithm given by Jayadeva and Bhaskara II for solving indeterminate quadratic equations. Bhaskaracharya II's works Leelavati, Bijaganita and Siddhanta Shiromani became canonical texts of the Indian mathematical and astronomical tradition. Upapattis or proofs in Bhaskara's texts give us the pedagogical advancements of that time. So not only do we get a lot of mathematics through these texts, we also get a glimpse to understand how math was in fact taught to people of different ages. We will learn a few verses from Bhaskaracharya's Leelavati in the course of subsequent lectures. Now, let us look at some highlight achievements of the medieval era in Bharatiya Ganita. In the medieval period, we see the flourishing of a lot of mathematical texts written in regional languages. Of these, the Ganita Sara Kaumudi, composed in Prakrita, of Thakura Feru, composed around 1300, and other works in Telugu, in Marathi, in Kannada, and other languages are found. Narayana Pandita's work, including the Ganita Kaumudi, included various breakthroughs, including magic squares, which we will learn in the course of subsequent lectures. The works of Jnana Raja, Ganesha Deivagnya, Surya Dasa, and Krishna Deivagnya include commentaries with upapattis in them. Upapattis are rationals or the equivalent of proofs in the Indian mathematical tradition. Madhava, who lived around 1350 CE, is considered to be the founder of the Kerala school of mathematics. He gave us the infinite series for pi, sine and cosine functions, and fast convergent approximations to them. Other works of note are those by Parameshwara and Neelakantha Somayaji, who has been credited with revising the planetary model. Neelakantha Somayaji's methods for finding cube is also something which we will learn in the course of this lecture. The systematic exposition of mathematics and astronomy with proofs has been given in the Yukti Bhasha of Jyeshtha Deva, and commentaries on mathematical texts such as the Leelavati and Yukti Deepika of Shankara Varyar give us a good understanding of various pedagogical approaches which mathematicians used at the time. Mathematics and astronomy flourished in the court of Savai Jai Singh as late as the 18th century. He also encouraged translations from Persian of Euclid and Ptolemy to advance the mathematical tradition. Now, let us look at the opening verses of Mahaviracharya's text Ganita Sara Samgraha, in which he explains why one should study mathematics in a beautiful verse. Let's listen to the verses now.
लौकिके वैदिके चापि तथा सामयिकेऽपि यः व्यापारस्तत्र सर्वत्र संख्यानामुपयुज्यते कामतन्त्रे अर्थशास्त्रे च गान्धर्गे नाटकेऽपि वा सूपशास्त्रे तथा वैद्ये वास्तुविद्यादिवस्तुषु.
In these beautiful verses, Mahaviracharya says that whether we are dealing with worldly affairs or Laukika, Vedika or spiritual matters, Samayika or religious practices, Kama Tantre, the science of Kama, Arthashastre or economics, or the different art forms that we have. Similarly, Supashastre or the science of cooking, Tatha Vedya meaning medicine, or Vastu Vidyadi meaning also in architecture. In all of these knowledge or art and science literature, we find the existence and relevance of mathematics. Subsequently, he says,
छन्दोऽलङ्कारकाव्येषु तर्कव्याकरणादिषु कालगुणेषु सर्वेषु प्रस्तुतं गणितं परम् बहुभिर्विप्रलापैः किं त्रैलोक्ये सचराचरे यत्किञ्चित् वस्तु तत्सर्वं गणितेन विना नहि.
He continues by saying that whether it is in the science of prosody, in the use of figure of speech, in composing literature, logic, grammar, etc., after listing all these domains, he says that it is futile to list all these domains and keep going endlessly, and ends by saying that math in fact pervades everything. That has been the holistic vision through which mathematics has been practiced, approached as well as taught in the Indian tradition. In our subsequent Bharatiya Ganita lectures, we will have the opportunity to learn some techniques through the beautiful verses, the marriage of poetry and math in the Indian tradition. we will look at some works of the many scholars who we have learnt about today and have the opportunity to enhance our mathematical skills and at the same time learn more about our rich cultural heritage. I hope that you enjoyed this introductory video to mathematics and it has gotten you all excited to learn more around Bharatiya Ganita. Thank you.